Above Earth, silently orbiting at 28,000 kilometers per hour, floats one of the most extraordinary creations in human history, the International Space Station, ISS. It is not just a spacecraft, nor merely a lab, it is a marvel of global collaboration, a triumph of engineering, and a shining symbol of peace in an often divided world. The ISS embodies our species' greatest hopes, our insatiable curiosity, and our capacity to reach beyond borders in pursuit of something greater than ourselves. From its earliest conception to its continuing legacy, the story of the ISS is not only about science or technology, but about humanity daring to live and work among the stars. It is a floating city in the vacuum of space, where scientists live in microgravity, peer back at Earth, and reach forward into the unknown, all while representing dozens of cultures and languages working in unison. The roots of this ambitious endeavor stretch back decades before the first module ever launched. The concept of a permanent space station had long lived in the imagination of humanity, first as the dreams of visionaries like Konstantin Tsiolkovsky, and later as serious proposals during the space race of the 20th century. Both the United States and the Soviet Union developed early space stations like Skylab and Mir, proving that humans could indeed survive in orbit for extended periods. However, it wasn't until the Cold War began to thaw that these rival nations considered working together. In 1993, following years of political transformation, the US and Russia decided to merge their respective space station plans, NASA's Freedom and Russia's Mir 2, into what would become the ISS. This extraordinary pivot from competition to cooperation opened the door for other nations, including Japan, Canada, and the European Space Agency, to join forces. What emerged was not simply an American or Russian venture, but a truly international mission, built by thousands of scientists, engineers, and space agencies from across the globe. Construction of the ISS was a feat unlike anything attempted before. It required transporting and assembling hundreds of individual components in orbit, all of which had to fit together perfectly despite being manufactured in different countries under different technical standards. The first module, Russia's Zarya, launched in November 1998, followed closely by NASA's Unity. Over the next decade, a steady parade of modules, trusses, solar arrays, and laboratories were ferried into space aboard space shuttles and Russian rockets. Each addition required intricate maneuvers, robotic assistance, and often spacewalks in the hostile vacuum of space. Despite the many dangers, ranging from micrometeoroid impacts to mechanical failures, the assembly of the ISS continued steadily, module by module, until it stretched to the size of a football field, and became the most complex and expensive engineering structure ever built in space. Maintaining such a station is a never-ending challenge. The ISS orbits Earth every 90 minutes and is constantly bombarded by space debris and radiation. Every system, from oxygen recycling to wastewater purification, must function flawlessly to keep its crew alive. Astronauts spend hours each day not only conducting experiments but also inspecting and repairing the systems that support them. Sometimes this involves high-risk extravehicular activities, spacewalks, in zero gravity, tethered only by cords, with Earth spinning beneath them. The need for constant supply runs led to the development of a fleet of support vehicles from different nations and companies, including Russia's Progress, SpaceX's Dragon, Northrop Grumman's Cygnus, and Japan's HTV. These spacecraft bring food, fuel, scientific equipment, and spare parts to keep the station alive. The ISS was never cheap. Its total estimated cost has surpassed $150 billion, making it the most expensive single object ever constructed. The United States has borne the bulk of this cost, with NASA contributing over $100 billion. Russia, Europe, Japan, and Canada have also invested heavily in both construction and operational support. Annual maintenance now costs between $3 to $4 billion per year. Critics often argue that such vast sums could be better spent solving problems on Earth. However, supporters point out that the technological advances, medical discoveries, and international goodwill generated by the ISS more than justify the investment. It is a long-term scientific platform like no other, yielding data that would be impossible to collect anywhere on Earth. Its existence has already led to significant technological spin-offs, ranging from water purification systems used in developing nations to robotic surgery techniques. The ISS has hosted astronauts from more than 20 countries and serves as a global laboratory in orbit. Here, in microgravity, scientists can study the effects of space on human physiology, test the behavior of cells and bacteria, and observe physical phenomena in ways that are impossible on Earth. Research aboard the ISS has helped us better understand muscle atrophy, bone density loss, immune system changes, and even vision impairments, all vital knowledge for planning long-duration space missions. It has also revolutionized the study of fluid dynamics, combustion, and materials science, offering a unique laboratory environment where gravity's influence is removed. More than a scientific lab, the ISS is also a symbol of peace and unity. While political tensions on Earth may flare, the space station remains a zone of cooperation. Russian cosmonauts and American astronauts have worked shoulder to shoulder through wars, sanctions, and diplomatic crises. The ISS has demonstrated that even bitter rivals can find common ground when working toward a shared vision. The spirit of unity has spilled over into education and culture, inspiring generations of students to pursue careers in science, engineering, and space exploration. Children across the globe have watched live transmissions of astronauts conducting experiments, speaking in multiple languages, and orbiting above all nations. The message is powerful: the sky is not the limit, it's just the beginning. Yet the true purpose of the ISS goes far beyond its current functions. It is a critical stepping stone to the stars. By living and working in low Earth orbit for more than 2 decades, we have learned how to keep humans alive in space for months at a time. This knowledge is essential for future missions to the Moon and Mars, where life support systems must be even more robust, and where resupply missions will be far less frequent. The ISS has allowed us to test closed-loop systems that recycle air and water, refine radiation shielding techniques, and study the psychological impacts of long-term isolation. It has also helped develop autonomous robotic systems and advanced docking procedures, all of which are crucial for deep space exploration. Without the experience gained from the ISS, the upcoming Artemis missions to the Moon and eventual crewed missions to Mars would be immeasurably more difficult, perhaps even impossible. As the ISS approaches the end of its service life, expected sometime in the early 2030s, its legacy will endure. Plans are already underway for new stations, such as the Lunar Gateway, which will orbit the Moon and serve as a base for future surface expeditions. Commercial space stations are also in development, with companies like Axiom Space and Blue Origin designing platforms for research, tourism, and manufacturing. These future ventures will stand on the shoulders of the ISS, borrowing its technologies, methods, and lessons. Even after it is deorbited, the spirit of the ISS will live on in every spacecraft that travels farther into the cosmos. It has set the standard for how humans can live and thrive beyond Earth. The International Space Station is not just an orbiting lab, it is a monument to human imagination, resilience, and cooperation. It is the physical proof that nations can transcend politics and rivalries to build something truly magnificent together. For more than 2 decades, it has circled the planet silently, a beacon of hope and a symbol of what we can achieve when we dream beyond borders. It has shown us the fragility of our Earth and the boundless potential of space. And as we look to the Moon, Mars, and beyond, we carry with us the knowledge, spirit, and unity forged aboard that miraculous outpost in the sky. The ISS is not just the pinnacle of space engineering, it is humanity's lighthouse in the void, guiding us toward the stars.
If you have enjoyed our videos, don't forget to subscribe and share.